is, excuse me, is the series that look like this. So in general, you are summing up fk from 1 to infinity, where fk is equal to, I missed the negative sign, let me add a negative sign in. So it's minus 1 to the power k plus 1. So, okay. So 1 over, so fk in this case is 1 over root k. So I could actually start from, so I should start from 2 actually, excuse me, because this is where it is. So if that's the case, I also don't need this plus 1, because then this would already be positive when k equals to 2. And you can see that this is actually decreasing to 0. Well, first, it is positive, and fk is going to be bigger than f of k plus 1, and moreover, fk tends to 0. So it meets the alternating series test. So the alternating series test implies that the sum of minus 1 to the power k, 1 over root k from 2 to infinity converges. And for the second example, you need to work out the first few terms, and as you try, you will see that the first term, when k equals to 1, this is translated to sine of 3 pi by 2, and then everything divided by 1 plus root 1, which is 2 of course, and then plus sine of 5 pi over 2, and translated to 1 plus root 2, plus sine of 7 pi over 2, translate to 1 plus root 3, and you see, you can try one more term, it's going to be 9 pi by 2, and divided by 1 plus root 4, etc. Okay, so then you need to figure out the actual values of the numerators. It turned out the first one is going to be minus 1 over 1 plus root 1. The second one turned out to be a positive 1, and that is 1 over 1 plus root 2. And then again, negative sign comes in for the third term, and 1 plus 1 over root 3, and then plus term. It becomes a positive sign, 1 plus root 4. Okay, and then negative. So as you can see, if you think about that, the general term is fk. I'll put it another way. You're actually summing over a series that resembles minus 1 to the power k, starting from 1 to infinity, and it is fk, and fk is given by 1 over 1 plus root k. And so this function obviously is positive, and the larger the k, the smaller it is, and fk goes to 0 as k goes to infinity. So by the alternating series test again, this series converges. So this series converges by alternating series test. So that completes the problem. And then the next one is a summation of a rather interesting series that is minus 1 to the power n and 2 to the power n over n squared. And in fact, this is an interesting series because if you think about it as in the last case, I think I should put a +1 there, yes, so that I get the sign correct. So you can have fk from 1 to infinity, and fk is going to be 2 to the n of n squared. All right, so it does have an alternating behavior that the individual terms alternate between plus and minus. However, if you look at the individual terms, namely the fk, although it is positive, but in fact this doesn't go to 0 as n goes to infinity. So it fails the alternating series test as such. But even though it fails the alternating series test doesn't necessarily mean that it diverges. It's just the alternating series test doesn't work. However, what makes the series must diverge is for the same reason, namely that the same condition. Because for a converging series, if you recall that the sum, if it is convergent, then this implies the an must tend to 0 as n goes to infinity. And so therefore, since we don't have this phenomenon for this example, so it must diverge. Okay, so that's the 4 examples. I think I would make this short and finish at this point as the first trial. The next one we would continue on the lecture notes. Let me know if you have any questions or opinion of how the presentation can be improved.